Welcome back to Spark Learning Session. Today I'll be talking about practice code along from the lesson. Let's begin. Let's start some initialization codes. Import find Spark. Let me copy the code from my other screen so that we don't have to type the whole thing. Okay, then from PySpark.ml we'll import something from there. ML regression. Import linear regression. There's some error here. Let me try to correct this. There's a red line here. Import import, right? Got it. There you go. Linear regression. Next, we need to import Spark session from pyspark.sql. We need to import Spark session. Let's initialize the Spark session here. Spark session dot builder dot application builder app name, and we want to name it. Let's name LR example for now, and getter create. Getter create. There you go. Now we need to still import additional features from ML from pyspark.ml dot linear algebra. We want to import vectors. In addition from that, we need to import pyspark.ml dot feature import vector assembler. Let me group them into single so that they are together. Let me run this. Let me start typing another command while it's running so that we don't waste any time here. Time is money, right? It is. Let's copy and paste the commerce name, the file we want to import to our environment. E-commerce customer.csv. This is not a real file, but it's actually created file by the author itself. So nothing to worry about privacy here. Why is complaining? It's complaining because there's no keyword called head. It says header. That's why it's complaining. There you go. Now let's try to see what's inside it. Let's see the column of this file, the print schema, and we have around 8 columns: email, address, avatar, interesting, average session, time on app, time on website, length of membership, yearly amount spent. These are really generic columns that we see in e-commerce website. Now let's see what data it has. Data show. It contains rows and it's just showing only 20 rows. What I want to do now is I just want to print out only contents of the first line or second line and see what we get. How do we do this? Let me show you. For item in data dot head to 1. What I'm doing here is I'm getting 2 lines from the top of the data set, and that's the data frame itself, and I'm going to the second index, that is second row of that data frame, and I'm printing out whatever I get, the each column of that data frame. Print item, that's each column of the data frame, and that's what I get. This is information of each information data frame, which is this part. It is spitting it out for you. Let me just look at the columns here. What columns does it have? I'm going to delete this. Data columns. Let's take a peek at the columns. What columns does it have? It has email, address, avatar, blah blah blah, which you already saw earlier. Now we need to create a vector of features. How do we do this? Let me show you. Assembler would be the feature. Assembler would be the machine that we want to create, and feature vector assembler. This is a machine, and this machine will create a feature for us, and we are going to define this machine. This machine intakes input column. Let me copy and paste the column names. This machine takes the column names. These are the column names we are interested in. What are these column names? These are column names are those that are only numeric columns. If you go here, these are average length session numeric, time and app numeric, time on website numeric, length of membership numeric, yearly amount spent numeric. These are all numeric columns, and we want to input those columns in our machine, and this machine will spit out a feature vector, and it will be named as features. The column name will be features for that output column. Features. Let me correct this one. There you go, we have that. Now let's use this machine to create what we need, the feature vector. Output assembler dot transform data. This machine will intake the data and spit out what we need. Let's see what this output has. What kind of columns this output has. For that, we need to do print schema. And it has around 7 columns. Beside yearly amount spent, should not have yearly amount spent, should it? what is happening is that it is creating one. It is taking the data column, it is taking a data, and it is adding a column on top of it, features, which is a which has only 1, 2, 3, 4, 5 columns there. Let's see. Let's take the sample of this. Let's take a sample of this. We want to let's see what does the features column have. Let's see that. Okay. Let's check out what the feature columns have. Select and features. I'm just curious. What is it? What does this have? Dot show. We want to see what's inside it. We have some made mistake here. It's correcting that mistake. And there you go. We have that what we need. Now, I want to see what's the first row of this. Let's take the output and look at the first row of that, shall we? Let's do it. Output head 1, and there you go. Do you see this feature column? It has 4 numeric columns in it. It's a composite feature column. It is an array of four numeric values there. Now let's create a new data frame where I select just features and value labels. Here label is true yearly amount spent. That's what we are interested in. Final data. Final data output dot select. We are interested in these two columns, features and yearly amount spent. Let's do that. Now we have that data frame created. Let's see what's inside it. There you go. It's showing first 20 rows, and first column is the feature vector, and second column is the label that we are interested in. What we want to do is we want to split this data into train data and test data. Such that we can know what's accuracy of data, what's accuracy of our prediction. Let's split it data and test data equal to final data is our data set random split. We'll randomize the columns and split it into 70-30%. Will it work? It seems we need to still add the square bracket here. It works. What if I remove this bracket? Will it work? Let's check. Let's do trial and error. It does not work. We have to put the square bracket. Now we want to get some statistics about the data frame we created. Train data is a data set we are training on. Describe, and let's see what this described data frame have. Described data frame will have, once you describe this data, it will give us count, mean, standard variation, minimum, maximum of the yearly amount of the label. It says there are 346 labels. 501 is the mean of this label. Standard deviation is 79. Minimum is 266. Maximum is 769. 79 is the first standard deviation. That's what it's talking about here. The first standard deviation is 79. Let's do the same thing with the test data and see what it has, so that we are comfortable with what we just created earlier. Let's do it. Well, it's not showing. It says test data is not defined. How is that possible? Did we do it earlier? Yes, we did. We made a mistake. Let's run the command again. Let's describe it again, and let's run it again. Now it will work. There you go. Next, we need to create a linear regression model. How do we do that? We do it by this. We need to say linear regression, and the level column, the feature column is going to be the feature itself, but the level column will be yearly amount spent. Since it's not the default one, we need to prescribe that. Let's prescribe it, the level column here. Let me just copy and paste it so that I don't need to type it and there's no mistake. We don't want a mistake, do we? No, we don't. There you go. Now we have the linear regression. We define a linear regression function. We use that function to create a model. Linear model will take the data, and linear model will fit that on the top of the data. Train data. We just train our model. Now once we have our model, we need to test it. Test results will be result we need equal to LR model dot evaluate. We want to evaluate this model we just created and see how it performs on test data. Once we have our result, we want to see what's inside it such that we can evaluate what we have here. Test result, residuals. That's residuals. Show. And we want to see what residuals it has for each of the data points in the data frame. But this does give us much information. We need some more concrete numbers, such as the summary information of residuals, so that we can make some judgment call here. Test results. Test results dot root mean square error. What is the root mean square error of this test results we have? It is 10. How about R2 or of this correlation of this test result with the explanatory variables? How much the variance of y is explained by explanatory variables? That's what it's asking here. R2. R2 is what we need here. 1 is 100%, 0 means it doesn't explain at all. There is no relationship with the relationship variable. That's what it is. R2, 0.997. It's really good number here. 0.97. Now we want to get some statistics of the final data to see what we have here. What is final data? Let's go and see. We want to see. We want to look at the final data and see some. Look at some statistics from this table. Let's see what it has, and then we'll calculate some statistics for this one too. These are two columns: future and yearly amount spent. I want to create some statistics for this. Describe, show. I forgot some columns bracket here, so let me run this again. It says mean is 499 for this. Remember, this final data has been split into trend data and test data, and we did the same thing with trend data and test data with the mean and with the mean. Here we are just looking at the final data and looking at some test statistics as we did for final data and test data. That's all about. That's about it. Nothing more than that. Now we want to create some data that we want to predict and see how it's how to predict some labels. We want to have some features without any labels, and for that we need just we'll extract the features from test data because we don't have anything else right now. That's the only way I can do some predictions without some labels because I don't have any other data without any labels. So I'll just extract the features from the test data. This is unlabeled data I just created here. Now let's see what's inside it. Dot show. You have some feature vectors. Now we need to do some predictions using the model we have created, which is LR model. LR model and transform that. Use that means transform that, execute the model on the unlabeled data. And we want to see what the prediction looks like. Dot show. There you go. Do you want to compare some predictions here? How does it look? We can do that. Let's see how well does it do. Test data dot show. $406, year 397. It predicts 397. The true result was 461. It predicts 449. That's how it went. True result was 330, and it predicted 324. It's pretty close. It's pretty close. We are at another lesson. Let me quickly summarize what we talked about today. We talked about creating a linear model. First, we imported a CSV file into our environment. Then we inspected the file and see what kind of data it has. Did exploratory data analysis. We then selected only numeric columns for our linear regression purpose. Then we created a vector assembler. We created a vector, a machine, a machine called assembler, which is a vector assembler using the numeric columns. This machine produced a vector called output, which had original data plus a feature vector tagged at the end of it. Then we inspected that feature vector. Then we use select to select only features and label information to a data frame called final data. Then we use the random split to split data into train and test data. After that, we created a linear regression function, and then we use that function to create a linear model on top of training data. Then we tested the training data, and after training data is created, we evaluated this information using test data. And after evaluation was done, we created an unlabeled data using test data, and we predicted the values on unlabeled feature vectors using our model. That's all for today. I will see you in next learning session. Thank you so much.